seemingly simple questions sometimes require profound knowledge of the universe to answer. Wherever in the universe, from the stars and planets to ourselves, everything is made up of chemical elements. But the question is, where do they come from? The scientists said that it is the Earth's crust. Of course, that's where the laboratories gather the chemical elements. But how does the Earth's crust have these things? The answer compels us to look deeply into the universe, tracing back to its origins and evolutionary process. 3 of the most common natural elements were formed during the Big Bang. The rest was formed in the extremely hot core region and from the explosive remnants of dead stars. To facilitate the formation and merging of the next generations of stars, this gas layer is further enriched, leading to the formation of planets, the fragrance of plants, and even the emergence of humankind. But the actual situation is far more complicated than we imagined. For many people, the periodic table of chemical elements is something unfamiliar and forgotten. A chart filled with mysterious symbols. The last time I saw something like that was on the wall of my chemistry classroom back in school. This is the principle governing the chemical properties of all discovered elements and even those yet unknown in the universe. This board should have become a cultural icon. Science is proof of humanity's courage in the perilous journey of discovery. The experiment was conducted in the lab using a particle accelerator, the forefront of cosmic exploration. However, until now, even science has never paid attention to the periodic table. Like a zoo filled with bizarre, one-of-a-kind creatures that someone dreamed up. How could anyone believe that natri, a highly toxic metal with such strong reactivity, could be severed by just an ordinary paper cutter? Meanwhile, Blottingkid is a deadly toxic gas with a pungent, acrid odor. Scent of food. What about hydrogen and oxygen? One is an explosive gas, the other strongly supports combustion. But when combined, they form water, which can extinguish fire. When examining these fascinating chemistry stories, we realize that elements play an incredibly vital role in the universe. Let's explore the periodic table from an astrophysicist. Hydrogen is the simplest and lightest element in the periodic table, with a nucleus containing only a single proton. This element was formed entirely from the Big Bang and is among the 94 most common elements in nature. Hydrogen makes up more than 2/3 of the total atoms in the human body. And over 90% of all atoms in the universe exist at every scale, even when considering a range as small as the solar system. The hydrogen in Jupiter's core is compressed under such extreme pressure that it functions like an electrically conductive metal rather than a gas. Therefore, it generates the strongest magnetic field among all the planets. The English chemist Henry Cavendish discovered the element hydrogen in 1766. While experimenting with water, but in the field of astrophysics. He is best known for being the first person to calculate the mass of the Earth. After accurately determining the value of the gravitational constant in Newton's famous equation describing the force of gravity. Every second of the day, up to 4.5 million tons of hydrogen nuclei move at extremely high speeds. When they collide, they are converted into energy and trigger a fusion reaction in the sun's core, where temperatures reach up to 15 million degrees. Henry is commonly known as a type of gas that, when inhaled, temporarily increases the vibration frequency of the trachea and larynx. Make your voice sound like Mickey Mouse. Hydrogen is the second simplest and most abundant element in the universe. Although hydrogen ranks second in abundance. But the helium content is still 4 times the total amount of all other elements in the universe combined. One of the key pillars of the Big Bang cosmological model is the prediction that in every region of the universe, at least 8% of the total atoms are Henry. They were also manufactured in similar proportions, passing through the primitive measuring sphere. All things in the universe arise from perfect harmony. Here are the natural English translations for both versions of the sentence. Certain regions in the universe can accumulate more than 8% of the Henry distribution effortlessly. But as predicted, no one has yet discovered any region in the galaxy with such a low quantity. About 30 years before being discovered and analyzed on Earth, Henry was discovered in the spectrum and corona of the Sun during the total solar eclipse of 1868. The name Henry originates from Helios, the sun god in Greek mythology. Has a buoyancy of 92% compared to hydrogen in the air. But thanks to its non-explosive feature, the Henry became the top choice for inflating balloons of all shapes. This ranks second only to the military in terms of demand for the Henry element. Lithium is the third simplest element in the universe. Like hydrogen and helium, lithium has 3 protons in its nucleus and was produced by the Big Bang. But helium can be produced in the cores of stars. Lithium is destroyed in all known nuclear reactions. The Big Bang cosmological model also predicts that, in any region of the universe, the proportion of lithium atoms found does not exceed 1%. To date, no galaxy has been found to contain a lithium abundance exceeding the predicted threshold of the Big Bang model. S upper limit and lithium. Carbon is the element that appears in more compounds than all other elements combined. Based on the abundance of carbon in the universe produced by various types of stars, swept up to the surface and released a significant amount into the galaxy. No element is more suited to serve as the foundation of chemistry and the diversity of life than this. In terms of prevalence, oxygen is not much less common than carbon. Forged and freed from the remnants of exploded stars, both oxygen and carbon are essential elements that make up life as we know it. But what about life forms we've never known? Could there be life based on silicon instead? Silicon is located directly below carbon in the periodic table. At its core, it has the ability to form molecules similar to carbon. But in the end, I still believe carbon will prevail because it's 10 times more abundant than silicon in the universe. But that alone was not enough to make science fiction writers put down their pens. They are still focusing on researching experts in the field of extraterrestrial biology. Imagine if one day we lived in a completely different world, one based on silicon. What would life be like then? Besides its role as a flavor enhancer in dishes, natri is also the most commonly used luminous gas in street lighting systems across the country. They shine brighter and have a longer lifespan compared to incandescent bulbs. Sooner or later, they will be completely replaced by LED lights, which are not only brighter but also cheaper. Natri lights come in 2 common types: high-pressure lamps with white-yellow light and low-pressure lamps that emit orange light. It turns out that any kind of light pollution has a detrimental effect on the field of astrophysics. Low-pressure sodium lamps are the most energy-efficient type, because we can easily remove the noise from the telescope data. Aluminum makes up nearly 10% of the Earth's crust, yet ancient people were completely unaware of its existence. Our grandparents weren't very close to it. This element was not isolated and identified until 1827, and it wasn't until the late 1960s that it became one of the most common household appliances. This is also a card box, but it's made of aluminum. Unlike the usual paper boxes, here an aluminum box is used. Once polished, aluminum forms a nearly perfect mirror-like surface capable of reflecting visible light. And this is also the most preferred method for applying the mirror coating to the majority of modern telescopes today. Titanium is 1.7 times denser than aluminum, but its strength is more than twice as high. Thus, titanium, the 9th most abundant element in the Earth's crust, has become a precious and versatile material of the modern era. For example, manufacturing military aircraft components requires materials that are both durable and lightweight. Throughout all regions of the universe, the number of oxygen atoms always exceeds that of carbon atoms. After each carbon atom bonds with an oxygen atom, it becomes conductive. The remaining oxygen will bond with other elements, such as titanium. The spectra of red stars primarily exhibit features attributable to the presence of titanium oxide. This is nothing unfamiliar to world-famous stars. The reason the sapphire and ruby on the back exhibit a dazzling star-like shimmer is due to titanium oxide impurities scattered within their crystal structure. Moreover, the white gasket on the outer shell of the astronomical ring machine is also made from titanium oxide. This is a material with high reflectivity in the infrared spectrum. As night falls, I lie in a wide hammock, surrendering to the tranquil stillness. The temperature around the telescope quickly equalizes with the nighttime air temperature. Helps the light from stars and other celestial objects appear sharper and clearer. And although not directly named after any celestial object, Titan is the largest moon of Saturn. From many perspectives, iron deserves to be considered one of the most crucial elements in the universe. Massive stars produce elements in their cores, in order from helium to carbon, then from oxygen to nitrogen, and so on. Iron is in group VIIb of the periodic table, with 26 protons and at least as many neutrons in the nucleus. The unique aspect of iron lies in the fact that it has the lowest energy per nucleon compared to all other elements. This means something very simple: if you split an iron atom through a fission reaction. When absorbing energy, they combine iron atoms through fusion reactions. They will also absorb energy. However, the primary role of stars is to produce energy. When massive stars produce and accumulate iron in their cores, they stand on the brink of death. Without an abundant energy source, the star would collapse under its own weight. And it immediately erupted violently in a massive explosion, known as a supernova. Brighter than 1,000 suns for more than a week. Gallium is a soft metal with an extremely low melting point, so low that, like cocoa butter, it melts the moment you touch it with your hand. Beyond this entertaining performance, spacetime physicists show little interest in Galli, except when it is used as material in Gallic-Leroy's experiments. The passage is used to measure and detect neutrinos while excluding particles originating from the Sun. In this experiment, scientists monitored an extremely large underground reservoir containing liquid Gallic-Leroy. Check whether there are any interactions between neutrinos and gallium nuclei that could transform them into swaimani. That collision would emit a small flash, recorded each time the nucleus is struck by a proton. The issue lies in the discrepancies surrounding solar neutrinos. The issue here is that the number of detected neutrinos is lower than predicted by solar theory. The problem was solved by using telescopes like these. All forms of the element technetry are radioactive. It's no surprise that we can only find it in particle accelerators, and nowhere else. Where we create products tailored to your needs. Technetros. For reasons that remain unclear to this day, technetry inhabits the atmosphere alongside a specially selected group of red stars. This point alone isn't enough to raise alarm, but the issue lies in the fact that technetry has a half-life of merely 2 million years. It means its lifespan is much shorter than that of the stars where it originates. T have formed with this already in place, because if they had, they wouldn't. There is currently no known mechanism that can produce technetium in stars. And then, it was brought to the surface for clear observation. This has given rise to many intriguing hypotheses, but so far, astrophysicists have yet to reach a consensus. Along with osmium and platinum, iridium is one of the 3 heaviest elements in the periodic table. This mortar is about 0.05 meters long and weighs nearly as much as a car. Iridium is one of the most effective paperweights in the world, capable of withstanding any office fan breeze. Iridium is also the most eloquent testament to world history. A thin layer of iridium has been found worldwide in geological strata. Located at the boundary between the Cretaceous and Paleogene periods, dating back 65 million years. At that very moment, it was also the time when all land-dwelling creatures larger than a suitcase went extinct. Includes gentle dinosaurs. Iridium is very rare on Earth's surface but quite common in metallic asteroids about 10 kilometers in diameter. Upon impact with Earth, it would instantly vaporize, scattering atoms across the planet's surface. Therefore, no matter which hypothesis you support about the cause of the dinosaurs' extinction, topping that list would undoubtedly be a massive asteroid, as colossal as Mount Everest, hurtling from space straight toward Earth, bringing utter destruction. An unknown element was discovered in the debris from the first hydrogen bomb test on the Eniwetok Atoll in the South Pacific. On November 1, 1952, it was named Esthene in honor of Einstein. 11 elements in the periodic table are named after celestial bodies orbiting the Sun, including helium, which originates from Greek bringer of light, selenite. This element is always associated with the element tellus, and this is the name of Earth, derived from the Latin word thelus. On January 1, 1801, Italian astronomer Giuseppe Piazzi discovered a new planet orbiting the Sun in the vast, notable space between Mars and Jupiter. Continuing the tradition of naming planets after Roman gods, this planet is called Ceres, named after the goddess of agriculture. Ceres. At that time, the scientific community was so thrilled that they decided to honor the event by naming the first element discovered after that day cerium, Ceri. 2 years later, another planet was discovered orbiting the Sun within the gap between Mars and Jupiter, where Ceres resided. This new planet was named Pallas, after the Roman goddess of wisdom. And just as in the case of cerium before it, the first element discovered shortly after was named palladium in remembrance. The naming council ceased operations several decades later, when a series of similar planets were discovered, all sharing the same orbit. A more thorough analysis reveals that these objects are significantly smaller than the smallest known planets. A new asteroid has just been discovered in the solar system, a region densely populated with small, rugged chunks of rock and metal. Ceres and Pallas are not planets but asteroids, located in the asteroid belt. Today, we know that this belt contains hundreds of thousands of objects, slightly more than the number of elements in the periodic table. The English name for metallic mercury, a liquid that flows at room temperature, is also the English name for the planet Mercury. The fastest planet in the solar system is named after Mercury, the swift messenger god in Roman mythology. Eerie is named after Thor, the mighty god of thunder in Norse mythology, corresponding to Jupiter, the god of lightning in Roman mythology. After the element Mercury, no other element was named after it, but the subsequent elements, uranium, neptunium, and plutonium, were gloriously honored with their names. The element uranium was discovered in 1789 and named in honor of the planet discovered by William Herschel 8 years earlier. All isotopes of uranium are unstable and decay into lighter elements. This process simultaneously releases energy. Uranium was the main component in the first atomic bomb used in World War II. With 92 protons tightly packed in its nucleus, uranium is often considered the largest naturally occurring element. Heavy elements can also be found naturally in trace amounts in uranium ore deposits. If Uranus deserves an element named after it, then so does Neptune. Unlike Uranus, which was discovered shortly after the planet itself was found, Neptune wasn't discovered until 1940 using the Seclachang-Bachelet detector. Exactly 97 years since German astronomer Trongen discovered Neptune from a tiny speck of light in the sky. The French mathematician Joseph Le Verrier had predicted this earlier by studying anomalies in Uranus's orbit. Just as Neptune stands right behind Uranus in the solar system, the element neptunium also lies immediately after uranium in the periodic table of chemical elements. The Seclachang-Bachelet detector has discovered multiple elements that do not exist in nature. Plutonium is the element immediately following neptunium in the periodic table and is named after the planet Uranus. Mark Light Tombaugh discovered Pluto at the Lowell Observatory in Arizona in 1930. Just like when Ceres was discovered 129 years ago, everyone was incredibly excited. Pluto was the first planet discovered by an American, at a time when more precise data was not yet available. Many people consider it a planet with size and mass comparable to Earth. If you don't want to count the planets beyond Uranus or beyond Neptune. As measurement methods for the size of celestial bodies beyond Pluto became increasingly precise, it became clear that they were actually much smaller than initially estimated. Our understanding of the aspects of the region beyond Pluto only became truly clear by the late 1980s. Today, we learned that beyond the cold and lonely Pluto lies the smallest planet. The only slight difference is that it's even smaller than the 6 largest moons in the solar system. Like the asteroids, hundreds of other objects were later discovered. Scientists have discovered a celestial body with an orbit similar to Pluto's in the solar system. This is evidence of the existence of a previously undocumented small, icy celestial reservoir, known as the Kuiper Belt of comets. From this perspective, it can be said that Ceres, Pallas, and later Pluto gradually found their place in the periodic table. Plutonium, an unstable weapon, was the primary active component in the atomic bomb that detonated over the Japanese city of Nagasaki. Just 3 days after the uranium bomb exploded in Hiroshima, bringing an abrupt end to World War II. Weapons-grade plutonium can be used to power the radioisotope thermoelectric generators of the Chuzu space fleet, enabling their operations in the outer solar system, where the light intensity is too weak for solar panels to operate efficiently. Half a kilogram of plutonium can generate heat up to 10 million kW1s, enough to power an